All right, guys. So in this lecture, we are going to look at the chemistry practicals, and we are just going to basically do corrections for some of the things that we have done before in the other practicals. So I would love you to actually look at this one first before going through the other practicals. All right, because I'm not going to go too much in detail so that we'll not be having so many lengthy videos to watch. However, I would also want you to, when you are filling your manual, please try as much as possible to have variations. Now, what I mean by variation is don't just copy word to word. You can take my words, put it in AI, tell AI to modify it for you so that you have something genuine to write, not that you are copying what every other person in the school is copying. And I also understood that most of you wrote your results in the attendance sheet. Please write the result you wrote in the attendance sheet. Not be say you see X here, your own are P, you can go put P. Are you getting it? Don't just copy exactly what you have there. Is that okay? So the first practical, the aim of the first practical, we said earlier that the aim of this practical is to check for the solubility. Are you getting it? To check or to determine the solubility of different compounds in different organic solvents. All right, you can just decide to write it without even waiting for me. We say the aim is to determine the solubility of different compounds, pluralize it, in different organic solvents. So you have this result. I also understood that some of these things were changed. For instance, here they changed methanol. Are you getting it? So you had methanol here. Why here was toluene, they changed it to what? Acetic acid. Is that okay? So please change this to acetic acid in that other practical. And I believe that is the only thing you need to change. The aim is to determine the solubility of different compounds in different organic solvents, pluralize the solvents so that it will give you solvents in different organic solvents. All right? Now, the discussion is based on what you have actually seen here. You can decide to write like various organic compounds actually have different level of or different degree of solubility in different organic solvents. Now, this practical helps to actually determine the solubility of different compounds in different organic solvents. From the result obtained, it could be inferred that naphthalene is insoluble in water, given the fact that naphthalene is a non-polar solvent and water is a polar solvent, as polarity is a major determinant of solubility. All this is I'm saying, these are some of the things, just jot them down later, then at the end of the day, you now bring them together. Is that okay? So we says naphthalene is insoluble in water. This is expected because naphthalene is a non-polar solvent and water is a polar solvent. Is that okay? Now, also, naphthalene is soluble in hexane as they are both non-polar. And naphthalene is spirally soluble in methanol. This is expected because methanol is intermediate polarity. It has some functional group, like the OH functional group of methanol makes it a little bit polar as compared to hexane. Hence, the spirally soluble nature of it. Now, acetic acid is soluble in water. It is insoluble in hexane and soluble in methanol. Then for the solid unknown, this is where your discussion should base on. Now for the solid unknown, it is insoluble in water, is insoluble in hexane, and it is soluble in methanol. Now, for this particular thing, however, there is a little bit of discrepancy because if something is insoluble in water It's supposed to be at least soluble in hexane, so that we can infer that that thing is a polar solvent or a non-polar solvent. Are you getting it? But being insoluble in water, insoluble in hexane, and then it is soluble in methanol makes it somehow. However, we cannot really infer based on this result. I'm just speaking based on this particular result. Are you getting it? For your own result, if let us say it is soluble in water, but insoluble in hexane and spirally soluble in methanol, then we can say that solid unknown is a polar solvent. Why? Because it is soluble in water, right? But this case now, it is insoluble in water, insoluble in hexane. Because of the insolubility in water, we cannot say it's a polar solvent. Because of the insolubility in hexane, at the same time, we cannot also say it is a non-polar solvent. So there's a discrepancy. There's something actually wrong with this particular value. However, depending on what you get, if it is soluble in water and a little bit in methanol, you can say it is a polar solvent. Why, if it is soluble in hexane and it is insoluble in water, then you can say it is a what? A non-polar solvent. Non-polar solvent. All right. Then for this liquid unknown, say in water it is spiraling soluble, then in hexane it is soluble, methanol it is soluble. For this particular one, we can say that the compound is what? Is non-polar. Why? Because it is quite soluble in what? Hexane. Are you getting it? And also soluble in methanol to a little degree. So the polarity is not as if it is non-polar, but the polarity is not polar very well, because if it is very, very polar, it will be soluble in what? In water. So that is the explanation you will give for this particular one. Your emphasis should be on these two, solid unknown and liquid unknown. Is that okay? Based on your result, that's what I'm saying. Based on your result. If it is soluble in water, you know that it's a polar solvent. If it is soluble in hexane, you know that it's a what? Non-polar solvent. Why if it is in methanol? You know methanol is more like intermediate between polar and what? Non-polar. Like this one I would say it's spirally soluble in water. Spirally soluble in water means the level of solubility is actually very, very low. Is that okay? But a polar solvent cannot be soluble in hexane at all. So it means that the liquid unknown is a non-polar solvent. Is that understood? So that is what you should do in this first practical. And all the discussion I've said so far, you could just outline it. Solid unknown, for this particular person, it is insoluble in water, insoluble in hexane, soluble in methanol. Based on the result, I cannot really say much about this particular one. Are you getting it? Because it cannot be soluble in water and then insoluble in water and the same time insoluble in hexane. Are you getting it? Because water is a polar solvent, hexane is what? Non-polar. At least if it is soluble in one, it's supposed to be insoluble in another. Right? So that is that for this particular one. We'll see in the next one. All right. So that is that for the first one. Then, okay, we've actually said the aim. The aim is to determine the solubility of different compounds in different organic solvent. The discussion is just what I told you, that naphthalene is insoluble in all those things I said. You just explain them. All right. Now the next one is the experiment 7. All you just need to do is to copy what you have here. Are you getting it? Because most of you already have this result before. So it's not as if it's a new something to any one of you. All you just need to do in this particular one is copy what you have here. You have the physical test. The substance that was given to you, the alkanol is ethanol, is a liquid. Aldehyde is ethanol, is a liquid. Phenol, they gave you salicylic acid. I've taught you something on salicylic acid, where we got salicin, and then we have acetylsalicylic acid, aspirin, for treatment of pain as an analgesic. We said something like that. Is a what? A solid. Then for color, each of them colorless, and then salicylic acid is white. Odor, alkanol is odorless. It has a characteristic smell. Ethanol has a characteristic odor. Ethanol is pungent. It has a very rotten smell. And then ethanol, we said, is pungent. Combustion, all of them are flammable, apart from salicylic acid. Solubility in water. Are you sure Salicylic acid is not soluble in water. Is it insoluble in water? Right? I've said it's insoluble, but it's supposed to be soluble in water because of the different functional group that is there. Just write what you have there as your result. All right. Then for litmus paper, neutral, this one is ethanol is acidic. Salicylic acid, of course, is an acid, so you expect it to be acidic. Aqueous solution with dilute sodium hydroxide. Soluble, no PPT form. Soluble, yellow PPT form. Insoluble, white PPT formed. All right. And then the next one is other compounds given to you. We are given toluene, amine, carboxylic acid. All these on their combustion. Are you sure? Highly flammable, inflammable. Benzoic acid. Are you sure benzoic acid is not flammable? It's supposed to be flammable. Let me just confirm something. I'll be back. Benzoic acid, flammable. Is it flammable or not? It's supposed to be flammable. But report what you have, exactly what you have. If it is inflammable, write it as what? Inflammable. If what you have is flammable, you did the practical now. If what you did is not, you didn't get answer, just copy what you have here. Are you getting it? Then solubility in water. Toluene is insoluble. Ketone, isobutyl ketone, insoluble. Aniline is insoluble. And then benzoic acid is insoluble in water. I want to confirm something. Because from what I know, one of them is supposed to be soluble. All right? So normally at room temperature, it will be insoluble. All right. Then aqueous solution with dilute sodium hydroxide solution. This insoluble with gelatinous precipitate form. Then this one soluble. Then there's one with HCl solution. That one, because of space, we didn't actually write it. All right. So that is basically that for this particular one. Is an easy something I want all of you to take note of. All right. Some of you have already written it before. You've written it from the result you got in your practical. Like I said, it's a practical. Some of these reagents they might have actually given to you might be bad. Are you getting it? Some of them might not be fresh reagents. So you'll be expecting a little bit discrepancy from theoretical values. When I mean theoretical value, from what we know for head, say this thing's supposed to be like this. Do you get it? But what they might have given to you is not that good. So when you put it at the end of the day, you might be getting results that are a little bit different from what is expected. Report it as it is. Is that okay? Now, let's see the next one. Let me increase the stroke size of this my stuff. La, 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 la. All right. Let's see the next one. The next one is experiment 10, detection of sulfur. So we want to detect sulfur present in organic solvent, e.g. solid methyl orange, 4-amino-benzoic sulfonic acid, and sodium benzoate sulfonate. Now, each of these compounds given to you, methyl orange contains sulfur functional group. 4-amino-benzoic sulfonic acid also contains sulfur functional group. Even sodium benzoate sulfonate also contains the sulfur functional group. So you have sample A plus sodium nitroprusside. Are you getting it? Now, they say the observation you have is that it turn purple. Sometimes you might write it turn violent. How do you spell violent again? Being a violet, not violent too. Are you getting it? It turn violet color after adding the sodium nitroprusside and later golden yellow. Now, the reason why it happens like that is because of the sulfur that is present. And it's only the sulfide ion that actually reacts. The sulfate and the sulfites do not react. Are you getting it? Only these ions. Because of the reaction of these ions with this sodium nitroprusside, that is why you have that purple or violet color. Are you getting it now? So if you have a purple color in this particular experiment, know that sulfur is present. So you can write what you have here. Sample A plus sodium nitroprusside turn purple after adding the sodium nitroprusside and later golden yellow. Sulfur what? Present. All right, so this particular one, sulfur is present. The next one is detection of nitrogen. Now, we said nitrogen can be detected using the Larsen test. Even the halogens can also be detected using the Larsen test. So how do we detect nitrogen? They say detect nitrogen in organic compounds, e.g. sodium methyl orange, carbamide, and phenyl ethanamide. Carbamide is urea. Your urea is something like this. Can you still remember structure of your urea? It contains 2 nitrogen atoms. So you should expect that nitrogen will be present in it. So they gave you a sample. Sample A plus ferric sulfate heptahydrate. It contains 7 water of crystallization. Now, this is 2-in-1 experiment. On heating, it turns dark orange. That is the first step. Then after heating, you leave it. Sample A, after heating, a black precipitate is formed. Now, this black precipitate is supposed to be Prussian, supposed to be Prussian blue. It's looking like dark, but when you look at it very well, it seems like one very dark blue color. Are you getting it now? So it's not necessarily a black precipitate, but rather Prussian blue precipitate form. So you can actually put a black PPT in bracket, Prussian blue PPT form, and the inference is that nitrogen is present. Because whenever you react any nitrogen containing compound with ferric sulfate heptahydrate, it's supposed to form that black PPT, which will Prussian blue PPT, which will look like a black PPT. But most of you, because you don't really know the colors, you just said the thing looks like black, but it's supposed to be Prussian blue PPT. Is that okay? So that confirms the presence of nitrogen. Now the next one is the detection of halogens. Now I told you when I was teaching you earlier that halogens can be detected using what we call the sodium fusion test. Can you still remember? We said halogens can be determined using what kind of test? The sodium fusion test. Here we said we form sodium extract, and then from the sodium extract, you now start reacting with each of the reagent. Example of one of such reagent is silver nitrate. So this practical is still 2-in-1. Is that okay? The first step in the practical is your sample B plus nitric acid. First step. You don't expect anything to be formed with nitric acid. The reason why you added nitric acid is so that nitric acid will remove other ions under interfering or other interfering ions. That is the reason why you have nitric acid present, to remove other interfering ions, so that only the chloride ion will react with what? Silver nitrate. Is that okay? Only the chloride ion will react with silver nitrate. So when you now react the sample B that have been treated with nitric acid with silver nitrate, a white precipitate is formed. The white precipitate, which is formed with silver nitrate, is silver chloride. Are you getting it now? Silver chloride precipitate. That is to tell you that chlorine is what? Present. So what we actually did here is a very simple something. You form silver chloride by reacting a compound that contains the chloride ion with nitric acid. Nitric acid isolated the chloride ion so that the chloride ion will react with what? Silver nitrate to form silver chloride precipitate, which is the white precipitate form. So by so doing, you've been able to determine the presence of what? Of chloride, of chlorine ions. Is that okay? More like it's a very simple experiment. It's something you have, people did something like this, ammonium cyanate. ammonium chloride. Okay, let's leave it. It's more like something like this. Yeah, something I wanted to write before. Plus ammonium chloride. Are you getting it? This is silver nitrate plus ammonium chloride. This nitrate group will always displace this NH4. So chlorine will now react with this, and then you are going to form what? Silver chloride as a precipitate plus what? Ammonium nitrate. This is one of the simple tests in the laboratory that is used for preparation of what? Chloride ion. All right? So that is that for this particular one. And I think that is the end of the chemistry practical. So just take note of the corrections that we actually made in each of these. Is that okay? And I have said that this particular one, your main discussion will be based on, because what they actually want you to do is to be able to identify which one will be soluble in which and which will not be soluble in which. I told you that anything that is soluble in water means that that thing is what? Polar. If it is not soluble in water, it means that it's what? Non-polar. Because water and hexane are like two extreme ends. Water is what? Polar. Hexane is what? Non-polar. It's very rare for you to see something that will be soluble in water and at the same time soluble in what? Hexane. Or insoluble in water and at the same time insoluble in hexane. It's either, if it is insoluble in water, it should be soluble in what? Hexane. If it is soluble in hexane, it should be insoluble in what? Water. So that is that for this one. Is there any other thing we've not looked at? A very simple something. So just run through it, complete your manual, and go and submit. Get an A.